Hello guys, so this is another very important and very interesting question where in this computer network scenario we are asked that in how many ways a packet which is started from here may reach from NS to this ND, that is the output node here. So we have to find out all the possible ways from which this can reach here at N of D. Okay, so this is clearly the combinatorial problem and we can solve it very easily, but here we have these intermediate nodes which can be tricky to handle, and these can be very confusing here, but this question can be solved in many ways. But the first and the foremost method here is this one. So suppose a packet is here. Okay, so we have a packet here, and in order to select the path from these three, what it has to do here, he will have basically three choices. Okay, so out of these three choices he will have to find any one of them. Okay, so after it, when it will reach here, so how many choices will it have here? So when it will reach here, he will have one choice to reach this N4. Similarly, this another choice, let me draw it with this red, this another choice from N1 to N2 to reach N5, and similarly this choice with which it will reach from N1 to N6. Okay, so these are basically the three choices when it will reach here. Similarly here for N2, let me denote it with this blue. Here for N2 it will have this choice one, similarly this choice and this choice, so it will again have three choices. And similarly this third one, it will have this choice, let me draw it with green one, so it will have this choice, similarly this one, and the last one is here. So again at any point here it will again have three choices. So here three again, and here at this third layer it will again have three choices to reach here. Okay, so these will be 3 3 3. Okay, so now we can see that these will be 3 in each layer, but what we have to do, either we have to write plus plus here or we have to write multiplication here. Okay, so which sign to use here? It is a bit confusing that which sign do we have to use here. So we can see that whenever this node will select any of the path here, it will also select the other path from that node as well. Okay, so this will be clearly the AND problem. Okay, so let me call it L1 and this L2 and this is L3. So clearly when it will come here, it will select L1 and L2 and L3. It's not possible that it will select L1 or L2 or L3. Okay, so this will clearly be the process where he will have to select any of these paths. Okay, so as it has to select all the paths, or he will have all the options here, here and here and here. So here this is the AND problem, and I have previously told you that for all the AND problems I have to multiply, and for all the OR problems I have to add the digits. Okay, so now here as this is clearly AND problem, so I have to use this multiplication. So it will be 3 power 3 and it will be 27. Okay, so here we have 27 number of different paths here. So many people may find it very confusing because they may see it like this one. And here they can see that this is at this point it will have this choice, similarly here it will have this choice and this choice, but they are not going to encounter it. Similarly at that condition they might have 3 plus 12 plus 12, which again will give you 27 paths, and due to those paths it will be 3 plus 2 here, this one and this one, multiplied by the three paths of this N2, which are this one and this one. Okay, and two parts of it which are these one. Okay, so these are again 2. Similarly for this one as well, and here they will get 27, but here this plus sign will be confusing because of our formulated scenario. Okay, so this type of questions can also be modeled like this, this and this. Similarly here this node, this node, this node, and last one here. So in order to draw it, what will happen, this is the first one, then this one, then this. Here it will get here or here or here. Similarly here as well, it will have again 3 connections, and here it will again have 3 connections, and last one here. Okay, so it is clearly be seen here that if this is n of s and this is n of d, so here at each step we have 3 3 and 3 choices, and again the same formulation we will get. But what was confusing here? So the only confusing thing here which we have seen was due to the availability of these intermediate nodes. Okay, but the problem here is just like this one, and if we just concentrate over the destination from here to this second layer, this type of questions will be easier to solve. Okay, so this is about the problem of this computer network type packets destinations and all the paths. In different applications we also have to find the optimal path which will give us the lowest losses, and similarly the shortest path from the ns to nd. Okay, so in those type of questions, these type of scenarios are quite often to encounter. Okay, so that's it for today, and I will see you with some more stuff which is related to the probability and random variables in our upcoming videos. Thank you so much, and I will see you soon.